Howdy, my name is Jake Doyle, and I'll be running through a quick demo of my team's senior design project, aPAD. We begin by configuring aPAD to work with the specific game, connecting to the hardware components, and configuring the biometric sensors. For this demo, I will be playing Forza Motorsport 4 on the Xbox 360. I start by loading a configuration profile we've prepared beforehand and connecting to the hardware. aPAD automatically attempts to connect to the sensors upon launch, so all I have to do is connect to the Cronus device. Next, I begin the relaxed calibration procedure. It's a 5-minute process that requires the user to remain as calm and relaxed as possible, breathing deeply and remaining very still. This step is vital to obtaining an accurate measurement of user stress level during gameplay because of the vast amount of variation in what's considered normal across different users. Since it takes a while, we'll fast forward a bit to the stress calibration. With the relaxed calibration complete, we can begin the stress calibration. This procedure aims to simulate the maximum amount of stress a user might experience during a normal game session by requiring the user to play a segment of the game on the highest difficulty setting. A real-time graph of the data being analyzed by the Zephyr bioharness can be seen on the graph in the upper left corner. Unlike the relaxed calibration procedure, this step can be ended whenever the user is ready to move on, as long as he or she has played the game for at least 1 or 2 minutes. Now that the sensors have been calibrated, we can begin the session. aPAD collects data from the sensors in a constant stream. Every 30 seconds, aPAD uses this data to determine 2 independent stress ratings on a scale of 0 to 10. The Zephyr stress index is determined by using a weighted analysis of the user's heart rate, respiratory rate, and heart rate variability. The Shimmer's index is calculated by analyzing peaks in the user's skin conductance, a response to stress controlled by the autonomic nervous system. These indices are then combined into a composite stress index, which is then used to adapt gameplay to the user's stress level. A real-time graph of the stress indices can be seen in the lower left, and a readout of the effects currently being applied to the user's controller are displayed in the bottom right. Here you can see that the invert x-axis has taken effect, and my car now turns in the opposite direction of my steering. As expected, you can see that my stress level is increasing in response to the added effects. Until I calm myself down and learn to cope with the added pressure, the game will continue to become more difficult. Here, the ignore input effect is dampening my acceleration. This has a somewhat calming effect, and my stress level decreases in response to the sudden lapse in action, removing the effect pretty quickly. This concludes our demonstration. We hope you enjoyed it and thank you for watching.